Welcome students. In this class we will be learning about encapsulation. Now the most important question is, what exactly is encapsulation? The basic way to explain encapsulation is, take the example of a Audi car. Now no one can see the engine, because the engine is actually encapsulated in the bonnet. So coming to Python, the concept of encapsulation can be explained or can be summed up in the following manner. That is, you have a set of methods and variables that you don't want the other parts of the code to get access to. So this is the simplest way you can explain or understand. Now what it exactly means is that you design a class and you put into the class all of the methods and variables that actually carry out operations for the class. That's another way to understand. Now, organizing information is critical. When you don't organize information, the entire code setup would be complete chaos. So encapsulation provides us a mechanism to organize the data, because if you just leave data lying around or distributed all across the entire code structure, then the chances of mismanaging and adulterating the code is high. So that means someone who has the permission to create an object can literally go into that set of code or that set of variable and send in some arguments that would damage the entire program. So you don't want that to happen. Now another important aspect in encapsulation is that you are using access modifiers to prevent the access. In other words, anyone who can create the object would not be able to access these variables and methods outside of that particular class. So having mentioned this, the best way to understand encapsulation is by means of an example. Now it is also imperative to understand that when we are talking about OOPS, object-oriented programming structure, there are 4 pillars. The first pillar is inheritance, which we have already studied. The second one is encapsulation. The third one is abstraction, and the final one is polymorphism. So all of these 4 pillars, they constitute the OOPS concept. Now you might be asking, why are we, whenever we are using OOPS concept, the main idea is that you don't want your entire code structure, what goes in, to be completely viewable by the user. So there is something called as the client side and the server side, and we have to take precautions in protecting the code. So that is also another important feature. So to reiterate, it's, as people might say, that encapsulation is nothing but you're protecting the data and you are actually camouflaging it. Nothing as such happens. The very word encapsulation is nothing but you are casing up the code, or you're packaging the code. You are having a code that is better organized. However, when you're using access modifiers, you are definitely going a step further when it comes to granting access of the data. So probably because of that access modifier getting involved in encapsulation. That would cause people to interpret encapsulation to be a form of a protection or a form of a security wall that is being built inside the code. So foremost, what I'm going to do is I'm going to start off with a class. So we don't need all of these. So we start with a class. So I have a class, and I have a class called as account holders. Now in account holders, I'm going to have 3 account holders featured. So it's actually a variable. So I'm going to say account holder Mark, and his account is 1200121, and I'm going to copy the account for Mark, and I'm going to paste this. So I'm just going to change this to 14, and this one to be as John, and this one to be as Luke, and I will change it to 15. So we got 3 account holders in the class, and this package is for a bank. Now what we are going to do is we are going to define a method, say account holder display. Account holder information display, and I will say print account holder Mark's account is, and then I will say plus str of account holder Mark. So the information is placed there. The only thing is that I need to place self dot. It wouldn't work if I don't do that. So I will copy this and I will paste it. Three times, and this one would be John's account, John, and this one would be Luke's account. Now if I were to instantiate by creating an object, say account holders info is equal to, I'm going to use this class and I'm going to create the information. Now an object is created. Now instead of this method, if I were to have a init, now let me just show you, and I'm running the program. Let me run it. Now you can clearly see Mark's account is featured. Probably I should have changed the name. So I'm running this and I get this information. So Mark's account is there, John's account is there, Luke's account is there. Now you see a very important aspect. I can simply create an object. The minute I created the object, I'm getting the information displayed. Now what if I can send in some calculations? I'm going to make a deposit there, and I will just create another variable, another set of variable for Mark, John and Luke. So I will say account balance is equal to, say, 100,000, and I will place this as Mark's account balance. Now I'm going to copy this and I'm going to paste it here. This is going to be Luke's balance. Let me also place your account balance. I don't want to place the deposit now. just take it off just to show you. Now the object is created. Now the minute the object is created, all the details are displayed. You know, in a sensitive place like a bank, you cannot reveal information of your clients. And in this case, the moment an object is instantiated, all the information is displayed. Now, if you are going to put this application online, then there is a probability of a serious breach occurring. Okay. Now, imagine we are sending some data. Say, I want to pass this. Initially, I gave an argument, but I did not pass an argument. But now, what I'm going to do is I'm going to pass an argument as deposit. And then, with this argument, what I'm going to do is pass in the information. Say, for example, I'm going to say 0, or I'm going to say $100. I'm passing this. Now this 100 should be taken in for the account holder balance. So I'm going to say self dot account holder balance is equal to deposit. Whatever information that you are passing is taken to be as deposit. So I'm going to copy this and I'm going to paste this, and I'm going to say John and Luke. So let's run this program and see what are we getting. I'm executing it. Can you see this? Mark's account number is so and so, and Mark's account balance is $100. And similarly, these are the balances for the clients. So what do we understand here? Just by one instantiation of the object for this class account holders, the person who's instantiating the object can wipe out the entire balance of all the clients featured in the account holders. So you are able to see what I'm able to show you here. Even if the code is presented to the user, or I would say presented to somebody who's coding, this is a high risk situation. The minute an object is instantiated by the programmer and it's executed, the entire balance is wiped out. Everything is finished. Now, how are you going to redo the things? How are you going to handle it? Say, for example, if you have a code which has got about 100,000 clients and their balances undergoing some important critical operations, and this new coder comes and this entire thing is given. Of course, people may give a justification, oh, there will be backup and this and that. Well, we can't go into those details. You know, those things are extra layers of measures that an organization is doing for its own protection, but we can't put those protection, or we can't bank on those protections and just leave our code being exposed to some person who is taking the office and having this code at his her disposal and instantiates an object and runs it, and that's it. This is doomsday. You follow what I'm saying? This is why encapsulation is so much critical in the implementation of the concept of OOPS. Now I can simply prevent this. So to prevent this from happening, so what we need to do is we need to actually redo the entire program, redo the entire code for this application. So what I'm going to do is I'm just going to take away this ability of passing the deposit via the init method. So I just want to take this off. So I'm going to copy it and I'm going to remove this off, and I will just keep the init method with the bare minimum. Now I will come back now within a few lines of code. So what I'm going to do is I'm going to declare a new method. Probably I can declare it after this init method. Over here I will say def account deposit. So this is going to be the new method, account deposit. Now in account deposit, no one should be allowed to access this method outside of this class. So just because someone instantiates the object, he or she should not be in a position to access this. Now we will have to put in some mechanisms for accessing this. So first and foremost, what I want to do is I just want to get some, if someone wants to deposit some money, I want to give a prompt. Once the deposit amount reaches, I'm going to say self dot account underscore holder underscore mark deposit. So imagine mark already has a deposit is equal to, so this is going to be self dot plus self dot deposit. So that's going to be the deposit account for Mark. Now Mark is starting initial deposit. So let me place in that deposit here for Mark. So this is a class variable. Mark's deposit is equal to 100,000. So that's the deposit amount. So now the challenge comes is, how are we going to access this? Now to access this, we can have, so you can clearly see this is a private method. Now I have created the object here. Now if I were to use this object in calling this private method, let me copy this and call this up. Okay, I don't need to pass anything to the init method here. So the minute I execute it, I'm going to see an exception. You see that? Now you can clearly see account holder is equal to the object instantiated and then balance. So there is a whole lot of exception that is being thrown. Now what we need to do now is I will have to clear this up. Okay, this is getting fired. The init method gets fired. That's fine. And when it comes to making the deposit or calling that account deposit, there is an exception. It says no attribute account deposit. And that is the reason, because it is a private method. We are actually calling a private method from the object created, and that's the reason an exception gets thrown. That's the first part. Now what we can do for the init method is, the init method is giving the account holders a number. Now we can restrict that also. So for that I'm going to create a new method. So it's going to be def, it's going to be open method. I'm going to give a prompt. So the prompt is password prompt. Password is equal to int of input please enter the password for the account. So the password is received, and I'm making a check. If password is equal to, say, the password that we are giving, 1 to, this is given, okay, 12001211. If this password is received, then we move forward. So we will say print enter the amount to be deposited, probably enter the account number, and I'll get the account number. ACCNO is equal to int of input. The account number is received. Okay, now if ACCNO, I'm targeting account holder for Mark, I'm targeting mark first. So if account holder mark is equal to ACCNO, probably this should be a class variable. Self.ACCNO is equal to what we received from this method. Then what we need to do is please enter the amount. Print, please enter the amount, and then I'm taking in the amount. Amount is equal to int of input. So the amount is received, and then after receiving the amount, I will have to deposit the amount. Okay, I will have to call this method. So I think I will take this off. I don't think I need this. So what I will do from here, I will call this. I will call this guy. I will call this method. So I will say self dot underscore underscore. So this method is called now after a check. So there is a check that is going on here. So if this is the case, then this method is called. Now over here, amount is asked, amount is requested, and then it is added and it is retained. Now if you want to print that, you can also get it printed. Okay, you can also say print the current balance. The current balance accessible for mark is plus str. I need to put in this self dot we are creating the object and we are calling account deposit entry. So from here we need to call this one. So account deposit entry, let me write this down, account deposit entry. It's not a private method, it's a public method. So account deposit entry is called. So it is requiring a password. We put in the password, and after you put in the password, you are asked to enter the account number. You're receiving the account number, and then if this account holder marks account number received is same, then we call it. After you finish, you can actually come out of it. You can call this method, okay, sys.exit. It's a built-in method, so you can run it. Let's check it out. So this is from the init. I'm not much bothered about the init. So please enter the password. So I'm entering the password. Please enter the account number. I'm targeting this number. Enter the deposit amount. I'm entering $1,000. Balance accessible, you see that balance accessible is 101,000. So this is a beautiful program. So clearly you can see that we are able to encapsulate the deposit using this protected, I would say, this private method. So no one can access it. To access it after the object is instantiated, I will have to call a method that is lying down over here, and from this method has a password check. Now this password has to be given, and only then after checking for the password, and then the account number is received and the account number is checked, and then the method is called. Now you can clearly see these three things. Because the init method is fired, I'm getting this display. Now we can prevent this by totally removing the init method. All I need to do is I can get rid of this init method. I don't need to have it. I execute it. Clearly you see that print, please enter the password for the account. So if you know the password for the account, then only you can access it. Then only it gets it. When you enter the password, say I'm entering the password, so there is a check. If the password agrees, then the account number is requested. If you know the account number, then you are given access. So it's asked what's the amount you want to deposit, say 2000. So now you get the balance of 102,000 being present in the account. So the idea in this case is, just by creating an object, we wouldn't be able to access the sensitive information, or we can't even pass the data here except for what we allow. So this is a clear example of encapsulations. Now we can go a step further. Now, as of now, if I want to access the account holder Mark's information, I can very well do it right from the object. Say I'm creating here, all I need to say is account holders -info dot, I can place in the account holder Mark's number there. I can just simply call and even get it printed. I can simply say print Mark's account details and place a concatenation symbol and convert it into a string and have it printed. So you see that Mark's account detail is already there. Now we can avoid this. How are we to avoid this? All we need to do is implement encapsulation, make them private. So that means nobody can access these account numbers except they are part of this class. So that means just because you create an object, you would not be able to access them. See that Mark's account details, you can't access them because they are encapsulated. How am I able to encapsulate, restrict the access? Because of access modifiers. So this is a powerful illustration by which we can use access modifiers to encapsulate the sensitive information for that particular class alone.